Well, welcome. I am Mr. Murphy, and in this particular video, we're going to be looking at skill number 11. In skill number 11, the purpose here is for us to come up with an equation in the form of our choosing for a table with a given set of data. For example, let's look at one that you'll be working on your own here in a second. So here we can see that we have a table with a bunch of data, and we're going to use that information to be able to come up with an equation. Now, like I said, we could come up with an equation in the form of our choosing. Well, what does that mean? What forms are we referring to? Well, let's take a minute and look at some of these forms. You might recall that we have the slope-intercept form as well as the point-slope form. And recall from the slope-intercept form that that's going to be in the form y equals mx plus b, where m represents the slope of the line, and where b represents the y-intercept. And it's important to remember it is the y-intercept, not the x-intercept. But that's the slope-intercept form, y equals mx plus b. And then we have the point-slope form. And the point-slope form is where we know the slope, and we use a coordinate, because we don't know in this case, we don't know what the y-intercept would be, so we pick another coordinate. We refer to that as our x1 and our y1. Put that information in and you have your point-slope form. And you may also recall if we have an equation of point-slope form and we want to get it in slope-intercept form, we can do that. It just requires us to do a little bit of algebra to rewrite it to be in the form that we want it to be in. But there's a lot of situations, and as you can see from the table that we were just looking at a minute ago, we don't know what the slope is. But you can see that for both of these forms, the slope-intercept form and the point-slope form, that we need to know the slope. That's going to be quite significant. So it's also important to remember the slope formula, which remember it's y2 minus y1 in the numerator on the top part of the fraction, and x2 minus x1 in the denominator in the bottom part of the fraction. So with that, why don't we take a minute and look at one together before you try one on your own. For example, let's look at this one. It says, given the following table of values, find a linear equation in the form of your choosing. So you can see again from this table that we don't know what the slope is, and we don't know what the y-intercept is. So my first step is to figure out, well, what is the slope? So I'm going to pick any pair of points here. It doesn't matter what pair of points you use. We could use 1 and 5 and 3 and 11. We could use the 1 and 5, the 2 and the 8. Again, it doesn't matter what pair we choose. I'm going to use these two, though. So remember the slope formula. It's the y2 minus y1 over x2 minus x1, and this gives us our slope. And I'm going to use this as our x2 and y2, and this will be our x1 and y1. So when I do that, it's going to be my y's. I'm going to subtract those. So that's going to be 11 minus 5. And then I'm going to take my x's and subtract those. So that's going to be 3 minus 1. Well, 11 minus 5 is 6. 3 minus 1 is 2. And so here I have a slope of 3. Now, I don't know what the y-intercept is, so I can't use the slope-intercept form. But I can pick one of the other points here, and I can put it into the point-slope form. So it doesn't matter which point I use. Let's use the 2 and the 8 this time. I could have used the 1 and the 5 again. I could have used the 3 and 11 again, or I could have used the 4 and the 14. But again, it does not matter which coordinate you use. But as long as we use our slope of 3. So I'm going to, again, the form that we're going to put it in is y minus y1 equals m, our slope, times x minus x1. Okay, so now let's use that point that we just picked. So it's going to be y minus, our y1 in this case would be the 8. Our slope we just found to be 3. And then it's going to be x minus the x1, which we're using as 2. Now technically, this standard says that we can write an equation in the form of our choosing, and we could leave it like this, and this would be point-slope form. Or if I wanted to get it into slope-intercept form, I could very easily. I'm just going to start by distributing the 3 through. and then I would add 8 to both sides. So I'd get 3x plus 2, and this would be in slope-intercept form. So again, either one of these would have been your answer, just that the first would have been in point-slope form, and the second one here would be in slope-intercept form. So why don't you guys take a minute and come up with an equation for a line for this one. Again, you can do either form, but when we go to check our work, I'll go ahead and I'll show you how to get both of the forms. But if you wanted to stop after the point-slope form, that would be fine, since this one is in the form of your choosing. So why don't you guys take a minute and pause the video, try this one on your own, and hit play when you're ready to check your answer. Okay, let's see how you did. Your first step should have been to find the slope. And so the slope for this one, again, it doesn't matter which pair of points you use. Let's use the 2 and the negative 2, and we'll use the 6 and the negative 4. So I'm going to take my y's and subtract those. So it'll be negative 4 minus negative 2. Now, you've got to be careful. Remember, minus a negative is the same as plus. This will be the same as negative 4 plus 2. And then I'll have 6 minus 2 in the denominator. Well, negative 4 plus 2 is negative 2. 6 minus 2 is 4. When I reduce that, I get negative 1/2. So my slope here is negative 1/2. So now, again, we don't know what the y-intercept is given this information. So I'm going to pick another point. It doesn't matter which point you picked. Let's say if you pick this one, 8 and the negative 5. So it'll be y minus the y value. Well, y minus negative 5 becomes y plus 5 equals our slope, which is negative 1/2, times x minus the x value, so x minus 8. Now, depending on the points you would have picked, you could have had a different set of answers. You could have had, for example, if you would have picked the 6 and the negative 4, you would have gotten y minus negative 4 would have been y plus 4 equals our slope, negative 1/2 times x minus 6, and that answer would have been correct. You could have picked the 4 and the negative 3, in which case your answer would be y plus 3, because y minus negative 3 become y plus 3 equals your slope, negative 1/2 times x minus the 4. Or you could have had this as your answer. Y minus negative 2 would give you y plus 2 equals your slope, negative 1/2 times x minus 2. And all of these, I should say, any one of these would have been your correct answer, and these would have been in point slope form. Now, if we wanted to get it in slope-intercept form, all of these would end up simplifying to be the same answer. Let's just pick this most recent one here and distribute the negative 1/2 through, in which case we'd have y plus 2 equals negative 1/2 x. And negative 1/2 of negative 2 would be a positive 1. Subtract 3 from both sides. I'm sorry, subtract 3. Subtract 2 from both sides. And when you do that, you get y equals negative 1/2 x, and 1 minus 2 is negative 1. I just want to show you that you would have gotten the same answer if you would have picked any of the other ones. Like, let's say if we would have picked the y plus 4, if I distributed that one with the negative 1/2 through, you'd end up with y plus 4 equals negative 1/2 x. And then negative 1/2 times a negative 6 would become a positive, and half of 6 would be 3. And for this one, we subtract 4 from both sides. So you get y equals negative 1/2 x, and 3 minus 4 is negative 1. So again, you can see that they end up with the same answer. It doesn't matter which equation you'd use, you'd end up with the same answer when you put it into slope-intercept form. Well, there you have it. This is skill number 11. So hopefully after watching this video, you have a better understanding of how to come up with the equations when you're given a set of data inside of a table. So with that, good luck as you try some of these on your own.